Okay, in this tutorial I'm going to quickly go through another type of reaction, so we call this a combustion reaction. You've probably heard this term before. We often use a more colloquial term, so just a more general everyday term called burning. So combustion is just when something burns, basically. So the definition is a combustion reaction is when oxygen combines with another compound to form water and carbon dioxide. Now, I should actually specify there are some other versions of oxygen, of combustion, so we call those incomplete combustion. When incomplete combustion occurs, you sometimes get some carbon monoxide or even just carbon, black soot, being formed. So I guess here, technically what we're looking at here is complete combustion. I should specify that. Okay, so guys, when we talk about combustion this year, we're generally just going to mean complete combustion. So incomplete combustion, you get some carbon monoxide or even carbon just on its own, which appears as sort of a black soot, is a form of incomplete combustion. So guys, an example here is burning methane. Methane is the gas that in a lot of schools, the gas coming out the tap is methane. I have a sneaking suspicion that the gas coming out of our taps might actually be propane, but I'm not actually sure. But I'll show you a quick video clip. So just fill the tray with gas. We can throw in a match, nice big flame. Alright, flip it over top, starve it of oxygen to put it out. One more time. Nice big flame. Alright, and yep, flipping over the container puts it out because it just starves the gas of any oxygen fairly quickly, and so the flame goes out. So another sign that oxygen is essential for that reaction to occur. So let's write an equation for that one. Okay, so guys, we said here that, alright, we started with methane, which is CH4. So things like this, we would give you the formula for them. If it's something you can use your ion table for, to figure out what the formula is, you could be expected to work it out for yourself. But something like this, methane CH4, would probably give you the formula of that. So combines with, if a combustion reaction, if it's burning, you know it must be reacting with oxygen, so you might be expected to figure that one out yourself. And you're expected to learn that for a combustion reaction, we're going to get carbon dioxide being formed, CO2, and we're also going to get H2O, water, being formed. And so interestingly, if any of you during the winter use a gas heater to heat your house, like maybe your living room, if you're using a gas heater is actually producing a fair amount of water. And that's why using a gas heater you often get, a house during winter can actually get damp. And often if you use a gas heater you'll see condensation building up on the inside of the windows. So a way to avoid that, use an electric heater. The only downside to that is an electric heater, I think, is generally a little bit more expensive to run. You'll also notice that if you've spent if you've had a friend over or something and they're for a sleepover or whatever, and they're sleeping on a mattress in your room or whatever, if you've got all the windows and things like that closed, you'll notice a lot of condensation building up on the windows the next morning as well. That's because basically a similar reaction is occurring in our bodies. We call that respiration. But as we breathe out, we also breathe out carbon dioxide and water. And so a room can get a bit damp from all the water that we're breathing out too. Anyway, we've still got to balance this equation, so let's have a look at that. So let's start with the most complex looking thing, like I said, and I think in this case I'll go with the CH4. So it's best to go with the most complex looking thing, but also avoid things when here we got oxygen in two things on the same side, so we might avoid that for now. Start with something that doesn't have that, and we definitely want to leave the oxygen, because it's a single element on its own, to last, because if I change the number of oxygens it's not going to affect anything else on this side, and I can leave that to last, and hopefully then it won't affect the numbers of anything else. So anyway, let's kick it off with methane here, CH4. So I've got one carbon here, and on this side I've got one carbon. Well, that's a good start, don't have to do anything there. Now we've got 4 hydrogens, H4, and on this side I've got H2. So I'm going to need twice as much, put a big 2 in the front. Now I've got 4 hydrogens here, and H4, I had 4 here to begin with. So 4 hydrogens here, 2 lots of 2 means 4 hydrogens over here. Okay, so on to my oxygens, O2. So I've got 2 oxygens over here, and over here I've got an O2 over there, and here 2 lots of oxygen, I've actually got another 2 over here. So if we put those together, okay, we've actually got 4 oxygens. Okay, and on this side we've only got 2, so I need 2 lots of that, put a big 2 in the front, and now we're actually balanced. Let's run through and check it. 1 carbon on this side, 1 carbon on that side. The carbons are happy. Okay, 4 hydrogens here, 2 H2O. Okay, so 2 lots of H2, 4 hydrogens on this side, yep, 4 on that side. Okay, 2 O2s, so that's actually now 4 hydrogens. So we've got 4 oxygens here, 2 lots of 2 is 4 oxygens, and over here I've got 2 oxygens here, 2 oxygens here, 4 oxygens, so this is now balanced too. Okay, so guys, I hope that helped. I've actually got one more example, so I thought we'd do one more example for combustion. This is quite a cool looking one, so this is one I did at home. So if you light a spirit, or a liqueur, something that's a high percentage of alcohol, it will actually burn as well. And alcohols burn very cleanly, so they burn with these beautiful blue flames. So I thought I'd show you that one. So you get these nice blue flames. Sometimes at bars and things they do that as a sort of a party trick. They sort of light a drink on fire like that. Obviously they blow it out before someone drinks it. But like I said, alcohol burns with a really nice blue flame. So let's write a formula for that one. Alright, so again, you wouldn't expect you to know the formula for alcohol. So alcohol, the type of alcohol that's in a drink, now that's not pure alcohol. So even though we call it alcohol, most spirits are, I don't know, anywhere from maybe 20 to 40%, maybe even slightly higher. But it's not pure alcohol. But the thing that's burning there, the thing you saw burning, which produced that blue light, is the alcohol that's in that liquid. So the alcohol is called ethanol, that's burning, and it has this formula: CH3, H2, OH. Okay, and it combines with oxygen, O2, to make, we said it's a combustion reaction, so carbon dioxide and water, H2O. Okay, which is also means if you are doing this with a drink, or if someone's doing this with a drink as a sort of a party trick, a bit of carbon dioxide is produced and water is left behind. It burns very cleanly, so there's nothing kind of toxic there produced or anything from burning it. So if we look at this, trying to balance it, well, what thing here looks like the most complicated? Well, probably this big whopping one over here. Okay, and the oxygen, we're definitely going to sort of try and leave that till last, like we said before. So over here, how many carbons have I got? Well, I've actually got 2 carbons. So let's maybe write it out underneath. Carbon, alright, we've got 2 carbons. Okay, and over on this side, oh, we've only got 1 carbon. So let's start by putting a big 2 in the front. Okay, so now we've got 2 carbons there too. Now how many hydrogens do we have here? Let's try and add that all up. 3, 4, 5, 6. So I've actually got 6 hydrogens. 1, 2, 3, 4, 5, 6. Okay, and how many do I have on this side? H2. Okay, alright. So to get 6 out of that, 3 lots of 2 will give me 6 hydrogens. 5, 6. So we've got 6 hydrogens there now. Okay, and over here we've only got the 1 oxygen. But we've got another 2 over here, O2 at this stage, so that's 3. And over this side, how many oxygens have we got total? So 2 times 2 lots of 2. So that's already 4 oxygens there. And then 3 over here. So that's 4, 5, 6, 7. So maybe I'll do like I did on the other one. Maybe we'll write that down the bottom. Maybe that'll be a bit clearer. So over here, on this side of the equation, we've got oxygen 1, 2, 3, 4, 5, 6, 7. So we had 2 lots of 2 here, 4 in this one, and then 3 lots of 1 over here. So 4 and 3 makes 7 total. Okay, so on this side I've got 3, and this side I've got 7. Ah, bugger. Alright, well let's have a look at how that worked. I've got 1 from over here, and I've got 2 over here. Well, we can still adjust this. So how many do I have to make it over here to have 7 total here? I've already got 1, so I need 6 more. 3 lots of 2. This gives me 6. So I've got 1 and 3 lots of 2 makes 7. 1, 2, 3, 4, 5, 6, 7. So you can see here 3 lots of 2 is 6, plus that one over there is 7. We've got 7 on this side now. So let's check that it all balances. How many carbons have we got? 1, 2. And on this side, 2 here, and that's it. 2 carbons on each side. The carbons are happy. Okay, alright, hydrogens. How many hydrogens do we have over on this side? Well, we've got 3 here and another one there, so that's 4. Oh, another 2 there, that makes 6. So we've got 6 hydrogens all together in that molecule. 1, 2, 3, 4, 5, 6. And on this side, my H2Os, 3 H2Os, so 3 lots of H2 is 6 on this side too. Hydrogens are happy. Okay, oxygens. So on this side, I've only got 1 here, but then, 3 lots of 2. So 3 lots of 2 are 6, plus that 1 over there makes 7 altogether, 7 oxygens. Okay, and on this side, 2 lots of 2 are 4, plus 3 lots of 1 plus 3 is 7 as well. 1, 2, 3, 4, 5, 6, 7 on this side. So that matches up across there too. Cool. So guys, I hope that helped. You know, practicing this formula, it's really quite simple. You can kind of pick what things you want to combine, or you can jump online. I'm sure you can find lots of examples. So that covers, I think that's the last type of reaction. I think there's one more video. We're going to look at exothermic and endothermic reactions. So we're almost at the end, but I hope you found that helpful.